Day 18 of 90, and today we're killing a bug pattern you've definitely written. Picture a notification service, an if-else chain branching on channel type. Email, SMS, push, Slack. 4 branches. Then someone adds Teams, and you crack open that method again. Every single time. That growing if-else is a symptom, and the cure has been in C# since version 1.0, Polymorphism and Virtual Dispatch. By the end of this video, you'll predict exactly which method the runtime calls, refactor the chain into a clean hierarchy, and know when not to reach for it. Let's go. First, what virtual dispatch actually is. When you mark a method virtual, the compiler doesn't hardwire the call at compile time. Instead, every object carries a hidden pointer to a method table for its real type. At runtime, the CLR looks up the override through that table. So when you have payment provider holding a Stripe provider, and you call provider's charge, the reference type is payment provider, but the runtime follows the table to Stripe's override. The variable's type decides what compiles. The object's real type decides what runs. That gap is the whole feature. Let's build it. Abstract class payment provider with public virtual bool authorize, returning true by default, and public abstract decimal charge, decimal amount. Now Stripe provider overrides both with public override. PayPal provider overrides only charge, it inherits the base authorize for free. Here's the payoff, for each var p in providers, where providers is I read-only list payment provider, you call p.authorize, and p.charge, amount. The loop has no idea which concrete type it holds. No switch, no casting. Add a new square provider tomorrow and this loop never changes. That's the open-closed principle made physical. Now the trap that creates invisible bugs, the new keyword. Say a junior writes public new bool authorize instead of override. It compiles. It even works when you call it through a Stripe provider variable. But the moment that object lives in a payment provider reference, the base method fires instead. Your override silently vanishes. Set a debugger watch on the call, step in, and you'll see it jump to the wrong method. The rule, new hides, override replaces. If you ever type new on a method to silence a warning, stop, you almost certainly wanted override. Next, performance, because virtual isn't free, the table lookup costs a few cycles, and it blocks inlining. Enter sealed. When Stripe provider writes public sealed override bool authorize, you're telling the runtime no subclass can override this further. The JIT can then devirtualize the call, resolve it directly, even inline it. On a hot path running millions of times, that matters. You get the polymorphic design plus near direct call speed. Seal the leaves of your hierarchy when you know they're final. It documents intent and unlocks the optimizer. So when should you not reach for this? 3 cases. 1. Structs. Try virtual in a struct and the compiler rejects it outright. Structs are sealed value types, no table, no inheritance. That kills a common misconception right there. 2. When composition beats inheritance. If your types share behavior but not an is-a relationship, inject a strategy or use a delegate instead of forcing a base class. 3. When an interface with default methods does the job later. See number 8 gives interfaces default implementations, sometimes that's all the polymorphism you need, without locking types into a single inheritance chain. And one modern win, covariant return types, see number 9 and up. Your base clone returns document exporter, but PDF exporter clone can now return PDF exporter directly, no cast at the call site. The override refines the return type to match the real class. Small feature, but it removes a whole category of defensive casting you used to write around polymorphic factory methods. Day 18 done. The takeaway, if you're still casting with as or branching on a type tag, you're fighting the runtime instead of using it, let the table do the dispatch. Subscribe for day 19.